So I wanted to walk you through how to use this flow chart. So I want you to get your homework assignments out so you can pause this. So I want you to get 3D, E, and F. So I'm just going to refer to different homework problems and talk about how to think about approaching this flow chart. Okay, so you've got 3D in front of you. All right, so when you start here, you start coming down the flow chart. I'm trying to get my pen to work here. Okay, start coming in the flow chart. Okay, so first off, you want to see if you can use the ratio or the root test. Remember, ratio test you must always use if there's factorials. And it's useful if there are lots of exponents. Root test can only be used if everything is to the nth power. This is the rarest of the tests. So if I'm looking at number 5 on 3D number 5, that would be appropriate to use the root test. Nothing else is going to work. So that's why you want to start thinking about ratio or root. Are those applicable? Number 2, number 3, and number 4 on 3D have factorials. So you must use the ratio test. You don't have any other options. Okay, so always you want to start thinking, is the ratio or root good? Okay, next you want to come down. So if it's not necessarily good for ratio or root, like number 6 or number 7, when you've got trig functions, you may not use ratio or root, right? So you come down and you start to think, is this a positive term series? Is it just a positive term series? So on 3D, on 11, I start asking the second question, is the 2n over n squared minus 1, does that converge or diverge? That's the positive term, right? So it means no negative 1 to the n, and there's nothing alternating, there's no hidden negative 1 to the n. So these are old converge or diverge questions. So if it doesn't have a negative 1 to the n, then you want to just go do your test for divergence, your basic comparison test, that's what the CT is, limit comparison test, integral test, p-test, or geometric. So if it's a positive term series and you go do a test and you find out it converges, that means it's absolutely convergent, because what the absolute means, the absolute convergence means is the absolute value converges. And if it's positive, yes, the absolute value converges. Okay, so if it's not a positive term, if you see a negative 1, so it's no, not a positive term, you see an alternating or a stealth hidden negative 1, like number 7, you're getting to recognize, right, on 3D, that's a hidden negative 1 to the n. Number 9, you're getting to recognize, that's a hidden negative 1 to the n. And so if it asks you, is it an alternating series, right, then you can say, oh, if it is, like number 10, number 8, anything like that, if it's alternating, then you go and ask, okay, does it converge by AST? If you find out that it doesn't converge by AST, you don't ever say diverge by AST, then you say, it must diverge by T for D, correct? That's the only way that you fall out of AST and you say diverges by T for D. Okay, so let's look at, let's change over to homework 3F. And on 3F, if I'm looking at a series, and again, remember these are the questions A, C, 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 or D. So this little vein right here could have been just the C or D, right? Positive term, and the answer would have always been yes, and then we would have just done our tests, right? So now we're on the ACCCD. Okay, so then if I come down here, let me erase this. So if I come down here, it's not ratio or root, it's not positive, so I'm going to do AST. So I'm thinking number 1 on 3F. So if I do AST, and I'll let you do it, I find out, does it converge by AST? Yes, terms are decreasing. Yes, limit is 0. Yes. So you need to state the original problem. So you need to say summation of -1 to the n over root n must 1 over n must 1 minus 1 converges by AST. Then you have to go check what the positive part does. That's what this little box is. And this, I'm going to use the comparison test, meaning the basic comparison, the limit comparison, the integral test, the p-test, geometric, all the things on the positive part. So if it converges, I have converge by AST, and then the positive part converging, that's the time I get absolutely convergent. If the positive part diverges, after I've gotten converge by AST, this is the only way you get conditionally convergent. So conditionally convergent is an alternating series that converges by AST, but the positive part diverges. Okay. So then we get to the hardest kind, or just kind of this offshoot kind, maybe not the hardest kind. Okay, so those are like 3F, number 12, and 13. So you come down, not good for ratio or root, because you've got a sine and a cosine. It's not all to the nth power. There's no factorial. Is it positive? Number 12 and 13 have a sine in the numerator, but because sine and cosine randomly go between 1 and -1, right? That's not going to be positive, and it's not going to be alternating, correct? Let's compare that with number 18 on 3E. 18 on 3E has a cosine, but it has 2 added to it, so that always makes it positive, because the smallest cosine gets is -1. So numbers 12 and 13 on 3F, that's this situation. It is not alternating and it's not positive. So what you do is you have to go check to see what the, there's absolute value bars missing. You have to check to see what the absolute value is doing. And you check what the absolute value is doing with the basic comparison test, limit comparison test, p-test. So big deal, forgot the absolute values in there. Sorry about that. Okay, so I check to see what the absolute value does. If the absolute value converges, it's absolutely convergent. If the absolute value diverges, I say it's divergent. So again, there's only one way to get conditionally convergent.